Okay, so today I want to look at a pretty tricky probability distribution. It's a question for GCSE stats. So, Jasper has 3 coins in an experiment. Jasper has 3 coins. In an experiment, Jasper flips each of the 3 coins and records the total number of heads that he gets. Jasper believes that each coin is biased so that the number of heads can be modelled by a binomial distribution b 3, 0.4. Show that the probability of 0 heads is 0.216. Well, how I like to start my binomial distribution questions is I define a variable x. So I'm going to say x equals number of heads. And let's not forget our formula for binomial distribution. The probability that x equals a particular outcome, little x, is our n choose x times the probability of success to the power of x times by the probability of failure q to the power of n take away x. Let's not forget, if this is our probability of success, this means our probability of failure q is the same as 1 minus p. So let's have a look. Probability that x is equal to 0 is our n, which is 3, choose x, in this case our x is 0, times the probability of success, 0.4 to the power of x, times by our probability of failure, q, or 1 minus 0.4, to the power of n take away x. So now, all you need to do is type into your calculator this. However, 3 choose 0 is just 1, and 0.4 to the power of 0 is 1. So really all you need to type in is 0.6 to the power of 3. And if I do that, that gets me 0.216 as expected. So it's really only one mark because you can just realize that all of this is just timesing by 1. So the probability you find 0 heads is just the same as finding tails 3 times. So 0.6 times 0.6 times 0.6. So all of this wasn't really necessary. It's just to show you how it follows a binomial distribution. Work out the probability that the outcome of the experiment is exactly 1 head. So we want to find the probability that x equals 1. So we're going to follow our formula. N choose x, so that's n is 3, choose 1 time, times by the probability of success, which is 0.4, to the power of x, which is just to the power of 1, which doesn't really make a difference, times by a probability of failure, 1 minus p, or q, which is 0.6, to the power of 3 take away 1, which is 2. So if I find that 3, how do I do this again? 3c1 times 0.4 times 0.6 squared, that gets me 0.432 exactly. So that is the probability of getting 1 head in 3 trials. Okay. Jasper carries out the experiment 100 times. The table shows information about the number of heads for each experiment. Determine whether or not the model B 3, 0.4 is a suitable model for Jasper's experiment. Well, we found out earlier using this model that the probability of getting 0 is 0.216 and the probability of getting 1 is 0.432. So we have this amount of chance of getting a 1. So if I do that 100 times, we're expecting around 21.6 times to land on a heads in 100 experiments. So what we're really expecting is we're expecting 21.6 heads in an experiment involving 100 trials. So I'm going to round that up to 22. And then for this one over here, we're expecting, we know the probability of landing on a 1 is 0.432. So if we do that trial 100 times, we've done the experiment 100 times, flipping the coin 3 times, we're expecting 43.2 times where you do that experiment, it lands on heads once. So we're expecting 43.2, which I'm going to round to 43. And then now we just have 2 and 3 left. So let's think back to our experiment. B, what was it? B, you flip it 3 times and your probability of success is 0.4. If I want to find the probability of landing on heads twice, I'm going to do my 3, choose 2, times 0.4 to the power of 2, times by 0.6 to the power of 1. Typing that into my calculator, I get 0.288. So again, if I'm thinking I'm doing my trial 100 times, and I have a 28.8% chance of landing on a heads twice. So that's going to give me 28.8 heads that I'm expecting, which I can just round up to 29. And then similarly, if I want to find the probability that x equals 3, I'm going to do my n, choose x, times my 0.4 to the power of 3, times by my 0.6 to the power of 0. So that's just the same as 0.4 cubed, which is 0.064. So if I take my 0.064 and I times it by 100, I get 6.4, which I'm going to say around 7. Okay, new page. So if we look at our results, when you actually do it, you get 24, but you're expecting 22. Pretty similar. When you did the experiment, you got 41 times, and then when you do an estimate, what you're expecting is 43 times you're landing on a head once. 30 times we got 29, pretty close, and then we got 5, and we were expecting 7. So all in all, the results are pretty similar. So the results are very close to what we expect using B3 0.4. This suggests B3 0.4 is a suitable model. So let's do a run through of what we just did. So the first thing we wanted to do is we wanted to find the probability of 0 heads. So we can just do that by doing the probability of getting a tails to the power of 3. Well, that's the same as doing the probability of getting a tails, then getting another tails, then getting another tails, and that gives us 0.216. And then the probability of x equaling 1, we can use our fancy formula up here. So we did 3 choose 1 times the probability of success to the power of 1 times the probability of failure to the power of 2, and that gave us 0.432. Now, Jasper is doing this experiment 100 times. So basically, 100 times, he's flipping a coin 3 times and counting how many times it lands on a head. And the probability of success each time we think is 0.4. So, out of in all of his 100 experiments, the coin landed on heads 0 times, 24 times. And then it landed on a head once, exactly, 41 times. And it landed on two heads, exactly 30 times. And it landed on all 3 heads, exactly 5 times. We figured out the probabilities of these things earlier. And we times them by 100 because basically these are the probabilities for him doing the experiment once. But if you want to figure out what we're expecting, if he does the experiment 100 times, we're going to times all these probabilities by 100. And that produced these results. These are what we're expecting. These are what we got. And the thing is, the results we were expecting using probability theory are very similar to the results we got by doing the experiment 100 times. So we concluded by the results are very similar. So that suggests, because the results are very similar, that suggests that this is a suitable model for Jasper's experiment.